Alright, hi guys, welcome to the Math Olympiad series where I try to explain problems from this book called The Lecture Notes on Mathematical Olympiad Courses. It's specifically for Singapore's SMO, and this is for senior section. So I'm doing this for practice for myself also, and hopefully benefiting others. So now we'll be looking at problem 4 of chapter 15 of volume 1. So we have this problem given that diagonals AC and BD of a convex quadrilateral ABCD intersect at T. The orthocenter of ABT coincides with the circumcenter of CDT. Prove that first, the convex quadrilateral of ABCD is cyclic, and also the circumcenter of CDT is on the circumcircle of the quadrilateral ABCD. Okay, so this first of all looks like a lot of words. So every time you see a geom problem, you don't know if it's easy or hard, so it's usually worth it to at least draw out what you're working with. So let me hop on the iPad, and the question is to the top left for some reference. Okay, so let's draw it out at least. First of all, we draw a quadrilateral ABCD. Let's draw the circle first, since you want to prove that it's cyclic. It is cyclic, right? Oopsies. Okay, so let's just draw any ABCD. Okay, hopefully this works. Let's do this ABCD. So BD intersects AC at point T. So first of all, let's mark out the orthocenter of ABT. Orthocenter of ABT would be if you drop this line down where it's 90 degrees, you drop this line down 90 degrees, and it intersects somewhere about here. Is this accurate? Because you see the second part, it says that the circumcenter of CDT is on the circumcircle of the quadrilateral ABCD. So if this is our circumcenter, it's not accurate. Hence you have to erase stuff. We probably need a different quadrilateral, and what we drew is not correct. So the first step is always get the diagram correct at first. If not, there's nothing really that you can do. So let's try this. AB and then C hopefully this is right. D like this, so CD and AC intersects BD at T. So ABT, it goes like this. Not the best drawer in the world. Probably one of the worst too, to be honest. Holy shit, can this be at the bottom? So this is kind of accurate. So let's call the auto center of ABT, let's call it O. So if you drop perpendiculars from all three sides, this one would be something like this. So O is the auto center, as you can see. And also, from the perspective of triangle CDT, O is also the circumcenter. So first of all, this line matches up. This line splits into two, and this line. So we know that our diagram is right. Now let's get to the proofs. Basically, first of all, we want to prove that A, B, C, D cyclic. Now, what I'm thinking is that okay, obviously BO is perpendicular to TC. And not only is it perpendicular. Sorry, I got something on the screen here. Not only is it perpendicular, because okay, this is first point, right? This is first point. Second point, the additional. Since O is also circumcenter of CDT, let's call this intersection point X. OX is perpendicular bisector of TC. So now we combine these two facts and we say that BO is not only perpendicular to TC but also the perpendicular bisector to TC. And since BO is the perpendicular bisector of TC, we can conclude that BTC is an isosceles triangle. So the intuition for this, right, is that if you know that that this is the perpendicular bisector. Perpendicular bisector means that along any point of the perpendicular bisector, for example, let's say this point, the distance from T and the distance from C is the same. So if we just drag this point upwards towards B, at B, we know that since it lies on the perpendicular bisector, the distance from B to T and the distance from B to C is the same. That's why it's isosceles. So this implies that simple isosceles triangle rule, angle BCT equals angle BTC, or the ones that I'm marking in red. Okay, now similarly, we can apply the same logic, because just now what we did was that we covered this side here. Now we can apply the same logic, exactly same logic, to this side. And the setup is basically the same, so just repeat that and you'll get triangle ADT isosceles. So this will imply that angle ADT equals angle ATD. So these two are equal. Now you have enough things to find out if ABCD is cyclic or not. Basically, the key idea is angle BCT equals angle BTC. This is from the first isosceles that we saw. So this is from the first isosceles, the linkage. Also, angle BTC is equals to angle ATD. This part is by the fact that if you have this setup, the opposite angles are equal. So this angle and this angle are equal, and we have it in this configuration like this. Let me just use a different color here. Okay, now ATD is also equals to angle ADT. This one is under the second isosceles triangle. So now we got angle BCT equals to angle ADT. What does that mean? Let me help you visualize. Angle BCT is equals to angle ADT, but ADT is also ADB. You just extend the line. So you see, this very clearly implies that ABCD is cyclic. So we're done. ABCD is cyclic like this, yeah. Now, second part is we have to prove that circumcenter, or in our case just point O, is on the blue circle, this point. So a way to do that is okay, so if you realize, right, let me just mark this out in green. This angle and this angle are both 90 degrees. So let's call this point M. So MOXT is cyclic. So it's this circle here. MOXT is cyclic. So this implies that angle AOX, I think, AOX is equals to 180 degrees minus its complementary angle. So we are saying that angle AOX is 180 degrees minus this. Okay, which is MTX. This is also equals to this angle BTC, because they're adjacent on a straight line. Angle BTC is also equals to angle BCT because of the isosceles, which is here. So let me just highlight what we found. We found in green that this angle is equals to this angle is equals to this angle. So we basically found that this angle and this angle are the same. So this clearly implies that if this angle and this angle is the same, that means this thing is also cyclic. C and O considered. So ABCO is cyclic. ABCO cyclic. Hence O lies on the blue circle. And we're done. So that's all for this question. See you for the next question.